Okay, so we have the last class before your test one. So today I'm going to give you again a quick overview and what are the important things that you should keep in mind. Okay, you don't have to memorize anything. Okay, but just see what are the things or what are the approach that you have to take for different problems. Uh, First of all, how many of you are accessing Google Classroom? Okay, so some of you are not looking at it. So I just advise you to look at because it has everything there, right? All the videos, all the other extra reading materials, whatever I've shared on WhatsApp, it's available there, right? So at one point you can go and look at everything, right? So that's important to keep watching there. Okay, so uh, that's one thing. Okay, second thing, I should a little bit talk about your syllabus actually first. I hope. Okay. Is it visible now? Okay. So now you see, these were the topics which I planned. This is the plan for your up to test one. Okay. And this is very specific. If you look at, so you should have some understanding of number system and real line, which I think you know, right? So like on the real line, between two rationals, there is irrational, all those kind of things. Rational numbers are dense on the real line, all those, right? Properties. Then something about functions, which is one to and on to and so on and so forth. Countable and countable is important thing, right? So we need to see certain examples for when something is countable and when something is not countable. So examples, you see very specific I have written. Sequential limit, epsilon and method, right? That is something which we talked about. And so you need to do two examples. You should have those two approaches. Basically, one is example of finding limit using epsilon n method, right? So like we have shown you 1 by n goes to 0, right? So you have to try different other examples. Similarly, so I think you need to do just one or two examples on your own and you are ready, right? So you will not be ready that, okay, you should memorize the steps. No, you just understand the concept, right? And that's all. Okay. Then second thing is examples of non-existence of limit using epsilon n, right? So no, in the first case, you remember the definition was uh, a sequence xn has a limit capital L as n tends towards infinity if for every epsilon possible. See, all these words are very, very important. Where it is, for every, where it is, there exists, all kind of things, right? If for every epsilon positive, epsilon is size of the neighborhood, basically, right? If for every epsilon positive, right, there exists capital N, a natural number capital N, such that mod of xn minus capital L is less than epsilon whenever, so mod of xn minus L is less than epsilon for every small n greater or equal to capital N. And this term, normally people call it for sufficiently large n. Okay. That means, for initial values of n, so small n, if so x1, x2, x3, x4, up to xn minus 1, capital N minus 1. Terms could be anywhere, I don't care. But after we go from capital N plus 1, capital N plus 2, and so on, all the terms of the sequence are in the neighborhood of capital L of size epsilon on both sides. Got the idea? Okay, you don't have to memorize anything. It's very simple thing, right? Just you see how it goes, right? So if somebody asks you to show that this limit is this value using epsilon n, so what you need to do, just write down the definition first. Then now Okay, so maybe I'll again write it for you. So we say that a limit x, a sequence n is equal to 1 to infinity has limit L if for every epsilon positive there exists a natural number n such that mod of xn minus L is less than epsilon for all n greater than or equal to capital N. This says that for sufficiently large n, right? Now, if I have to show that some limit exists, basically, I start with something like this, start with this inequality and try to find out the value of capital N. If I have to show that limit of this sequence is capital L, so what I need to do, just write down the definition first. And now, assuming this inequality, from this inequality, you have to somehow find out an inequality like this, where n is greater than or equal to some number. And that number you need to find in each case. Okay, that capital N you need to find. For example, in 1 by n case, if the sequence is 1 by n, this capital N was any integer greater than 1 by epsilon, if you remember, right? You take any integer greater than 1 by epsilon. So whatever epsilon you take, I'll take next integer to 1 by epsilon, right? And that will work. Why that will work? That you have shown, right? Starting from this inequality, you arrive at solving for n. So whenever I have to show that a limit of a sequence exists and its value is L, whatever L that could be, then we need to solve this inequality and find the value of n. If you are able to do this, you are done. Any question on limit of a sequence? Yes. No, n, yeah, of course, n will be some function of epsilon, but actually n is an integer, right? So you need to, so if it is 1 by f, if in the example of 1 by n goes towards 0, capital N turns out to be greater than 1 by epsilon, right? So I am because we are approaching as integer, right? Capital N is also integer. So anything bigger than 1 by any integer bigger than 1 by epsilon. Suppose epsilon is 2. So capital N will be bigger than half. So that will be 1. You can start with 1, right? Suppose epsilon is 5. So capital N will be greater than 1 by 5. So whatever the number, you take more than that, okay? And then you are able to do, right? So key idea, by varying the size of the neighborhood, you can control the value of capital N, right? By varying the size of epsilon, you can control the value of capital N, right? So if epsilon is too small, what will happen? If epsilon is very large, what will happen on value N? I think that observation you should see, right? Any idea what will happen if epsilon is too small?
Will be large.
Value of N will be large or small? Large. Very good. And similarly, if it is large, epsilon is very large, then what will happen? Yeah, so basically this variation is important. So I think you understood this concept. In any case, if you have to find that the limit of a sequence is capital L, just use the definition. Use this definition, solve the inequality, right? And find the value of capital N in terms of epsilon, right? Something will come, but remember, so like 1 by epsilon is not an integer, right? But you need to take some integer, capital N, which is bigger than that number, right? Take any integer, that will work, right? Okay, got the idea? Second part, if you have to show that that limit does not exist, right? So now remember, see, this is the difference. This result should be true for every epsilon positive. Now, if I have to show that something does not exist, I assume it exists. Write down the definition. Now, since I have to arrive at a contradiction, I can take specific values of epsilon, which will give us a contradiction. There we have to take a specific value. Okay. Anything that will show you that, okay, there is a problem in the result, right? Inequality. So that epsilon, how will you find? By observing, right? Somehow you have to arrive at a contradiction. What epsilon should I take so that I get in contradiction, right? And clear? Very crystal clear, right? If I have to show that limit exists, it should be for every epsilon positive. If I have to show that limit does not exist, you have to show that there exists a epsilon for which there is a problem in the inequality. Any question? Right? These two things are very, very clear, right? Okay, fine. Then we go to next one. So we have done number 3, right? Is crystal clear? Number 3 item. Now we go to number 4. So number 4, series convergence test can be done through epsilon and method, but I'm not worrying much about it. My stress is that you just remember those convergence tests. That is enough, because you see, you cannot keep on doing again and again. But if you're really overexcited, you can try to prove it, but there is no need actually. Okay, so that's why I've written. See, this is entire lecture plan. I have planned only 15 to 20 minutes and few examples. And I think I have done that only in your class, if you remember. This is the entire plan I'm showing you, right? Okay. Next, limit of a function. Now it's epsilon delta. And again, there is one example of existence and non-existence, right? Both. So you need to understand existence and non-existence. Let me talk about it now. So we say that limit of a function f of x limit of a function f of x as x tends towards a is L if for every epsilon positive there exists delta positive. For every epsilon positive, so epsilon is the size of the neighborhood of capital L, right? Capital L, remember? So if for every epsilon positive there exists delta positive such that mod of f of x minus L is less than epsilon, whenever 0 is less than mod of x minus a is less than delta, right? Now in this case, so if I have to show that the limit of a function f of x is capital L, so two problems comes. How do you find capital L? Okay, so here you estimate something. Okay, by looking at the expression, tries to estimate what will be the limit. Okay, as a shortcut, as a shortcut, you may limit निकाल कर अच्छा ये value है ना, now I'll try to prove it. That is okay. It's okay, but in general, you don't know. But what I'm saying that at least you estimate L, right? What is L? Sometimes happens you take some L and it does not work. You take some other L, right? That is the approach. But actually here you can you find out the limit and then you start with that. At least show it, right? Something is shown. So what you need to do here, for every epsilon positive, there is this delta positive such that, so basically by taking this inequality, is starting from this inequality, assume that this is true, you find the value of delta as a some function of epsilon. Find the value of delta. Delta of epsilon means delta depends on epsilon. So from this inequality and using this fact, try to estimate the value of delta. So here, there it was capital N, here you have to find delta from the definition, right? See the difference? Here, for every epsilon positive, there is this delta positive such that mod of f of x minus L is less than epsilon. Whenever 0 is less than mod of x minus a is less than delta. Why 0? Because the function may not be defined at a, right? So we need to avoid it, right? When we are approaching towards the point A, either from left hand side or right hand side, right? So that is a key thing. Any question here? Crystal clear? So if question comes that show that the limit of this is this, using epsilon delta, is write down the definition like this. Now, from these two inequalities, solve the value of delta in terms of epsilon, and you are done. Right? Got it? Again, the second case, that when you have to show that the limit does not exist, what you need to do? Write down the definition. Suppose limit exists, write down the definition. Then arrive at a contradiction for some specific value of epsilon. Right? take some epsilon and something. There you can take specific values, because you have to show, if you have to arrive at a contradiction, you don't have to do it for all values, right? Just some specific values for which there is a problem in the system, right? In the inequality. Got it? Clear? So this is the limit. And I think the popular examples that I have shown to you, that f of x is equal to 1 if x is rational, minus 1 if it is rational, all kind of things. Those are beautiful examples. Actually, if you focus on those examples, it is enough to learn entire calculus. बाकी ये सारे फालतू के बुक में जो प्रॉब्लम्स दी हुई है ना, वो करने की जरूरत नहीं है, right? You don't have to spend much time actually to study calculus. So I have given you very, very specific things, which if you focus your time there, you will really understand the entire concept, right? And the purpose is to understand the crisp of SAR, basically calculus का SAR समझना है. बाकी you don't have to memorize and this and that, right? जो कि habit रही है तुम्हारी, right? Okay, so that is the thing. So I think you know how to do it anyway. So both the cases are clear, right? In case if the limit does not exist, okay, so you have to arrive at some epsilon, right, for which there is a problem. And I think many times in one of the solved examples, you might have seen that if you take epsilon is equal to 1, right, and arrive at a contradiction, right, and then because the functions when f of x is rational or irrational, take x in the neighborhood which is rational, something else will happen, irrational, something else will happen, and you arrive at a contradiction, right? Okay, if I'm just recalling you, right, those kind of things will help you. Anyway, that was about limit of a function. Sorry, limit of a function. So item 5 is done. So item 5 is also done, right? I've told you how to handle both the cases, existence and non-existence. Now about continuity and uniform continuity. Again, using epsilon delta, and then one example of continuity, another example of non-continuity, and also one uniform continuity. These three concepts are there, right? A function is continuous, function is not continuous, function is uniformly continuous. All these three things can be handled with epsilon delta. So you need to understand that, right? So now let me start with the first one. Okay, we say that a function f of x is continuous at a point x is equal to a if limit exists, value of the function is there, and both are equal. That's the definition, right? But in terms of epsilon delta, if for every epsilon positive, there exists delta positive, such that mod of f of x minus f of a is less than epsilon whenever mod of x minus a is less than delta. Mod of x minus a is less than delta. This is the definition of continuity of a function, right? At a point x equal to a. So here what you need to do, this result has to be true. If the function is continuous at a point x equal to a, that means this should be true for every epsilon. Okay. So we start with this inequality, and using this try to find the value of delta in terms of epsilon, right? That is the trick. Here again, using this inequality, solve for delta. This is question mark. So this is when you have to show that the limit, when you have to show that the function is continuous at a point x equal to a. Write down the definition, start with this less than epsilon business, and try to estimate the value of delta using both the inequalities, right? Because mod of x minus a is less than delta. So ultimately trick is what? Underlying problem is solving those inequalities. वो तो high school का काम है, right? At least that I can assume. क्यों inequality तो solve करना आता है? Inequality की भी समरी दे दूं क्या? वैसे तो GH हार्डी की बुक मैंने बोला था, हार्डी पोलिया लिटिलवुड. But anyway, that's a beautiful book. I read it when I was at the age of 17. It's a really nice book. Talked about it because all these problems requires inequality business or kuch nahi, right? If you don't know how to estimate the solve certain inequalities, because you will use many times triangle inequality. There are plenty of inequalities, right? If you know those values, then you can estimate it. You can do it easily, right? So this is the case of continuity of a function at a point x equal to a. Second case, the function is not continuous at x equal to a. Take a specific value of epsilon for which there is a problem. Assume that the function is continuous, write down the definition and choose epsilon, the values of epsilon such that you arrive at a contradiction. And then you are done, right? Any question here again? Any question? Is it okay? Okay, so this is all about continuity of a function, right? So there are, as I asked so many questions, give an example of a function which is continuous at 3 points, 4 points, and more continuous, less continuous. Those are the beautiful questions. How many of you have solved it? All the questions or the T problems? नहीं किया किसी ने? क्वेश्चन नहीं किया तो फिर प्रॉब्लम होगा. ये मत सोचना कि लास्ट दिन हो जाएगा, कुछ नहीं होगा आखिरी दिन. Okay. Anyway, so that's all about continuity of a function. So what was the concept? Continuity and then uniform continuity, and then what else? 3 things were there, right? So not continuous, which I told you, right? So if not continuous, how will you show that? Assume it is continuous. In case of epsilon delta, choose a specific value of epsilon for which you arrive at a contradiction, right? Now I'll talk about uniform continuity. So what happens in this definition? Normally, when you try to find delta, delta is function of epsilon and the point under A. The point A under consideration. So normally in this definition, delta is function of epsilon and A, the point under consideration. This is something that always comes. If delta is only function of epsilon, then this is uniform continuity. It is independent of point A under consideration, right? So I think I have sent you yesterday a couple of applications, also uniform continuity and couple of other things. ये सारे तुम्हारे देखने के लिए ही हैं. आई होप कितने लोगों ने देखा है? वेरी गुड, वेरी गुड. तो कोई भी ऐसा कॉन्सेप्ट नहीं रहना चाहिए जो तुम्हारे समझ में ना आए, राइट? क्लास का टाइम लिमिटेड होता है, राइट? आई कैन नॉट कवर एवरीथिंग, राइट? फ्रॉम एप्लीकेशंस टू अदर थिंग्स, राइट? आपको की कॉन्सेप्ट पिकअप करने होते हैं. सो प्लीज डू लुक एट दीज थिंग्स व्हिच आई एम सेंडिंग टू यू. एनीवे, सो in case of function is uniform continuous, this delta depends only on epsilon. If you are able to show that, the function will be uniformly continuous. Now there are different characterizations of uniform continuity. I will write 1 or 2 so that you know. So one way is if you want to show that the function is uniformly continuous, you take this definition and solve for delta. If turns out that delta is only function of epsilon and not the point A under this consideration, you are done. But normally people don't use this method because this is a bit tedious, bit lengthy. So what they do, they have come up with some characterizations. So I'm going to mention some of those characterizations. One is that if you take any 2 arbitrary points in the domain of the function, right, and if you are able to show that mod of f of x minus f of y is less than epsilon, whenever mod of x minus y is less than delta, you are done. Since x and y are 2 arbitrary points in the domain, this is equivalent to the same definition that I'm giving to you, right? If you're able to do this, then we are done, right? So let me write down those characterizations for you. Okay. F is uniformly continuous. And this is a quite popular definition. If for every epsilon positive, there exists delta positive, such that mod of f of x minus such that mod of f of x mod of f of x minus f of y is less than epsilon whenever mod of x minus y is less than delta, and where x and y are 2 arbitrary points in the domain of the function. So this is a very popular trick to show that the function is uniformly continuous, right? Maybe I think because this is the only concept in epsilon delta where people find a little bit difficulty. So I will probably today give you another 1 or 2 examples so that you master this thing. I know this is the only thing. Baki sab to aasan hai, right? Okay. So essentially, if I ask you that show that the following function is uniformly continuous, what you need to do? see that if this characterization you can simplify. For example, I think in the class I have done that sine x is uniformly continuous for all real values, right? So you use an equality, the mod of sine of x minus sine of y is less than mod of x minus y. Right? If that thing is less than delta, where delta is equal to epsilon, you are done. Right? Got it? So here, let me take another example. Suppose f is a function from, so domain is basically, sorry, this is a comma a is a positive real number, right? From a to infinity, a is a positive real number, and the function is f of x is equal to 1 by x. So question is it continuous function? Is it uniformly? First of all, is it uniformly continuous function? Oh, actually, is it continuous function? I think continuity you can show easily. So if something is uniformly continuous, it will be continuous anyway. Right? If it is continuous, need not be uniformly continuous. These are the relationship that you need to understand. So now in this case, if I have to show that this function is uniformly continuous, where a is a positive real number, domain is this a comma infinity from the real line starting from some point a. Okay. So what I should do? Just I have to show that for every epsilon positive, there is this delta positive such that these conditions are satisfied. So I need to find what delta I should take, right? So that our job is done, right? So here also, using this inequality, I have to arrive at the value of delta, right? In as a function of epsilon, right? So here, if I take mod of f of x minus f of y is equal to, what is the value? Mod of 1 over x minus 1 over y is equal to what? Mod of x minus y divided by mod of x into mod of y. Agree? यहाँ तक सब सही है? Okay. Now x and y belongs to this point. I mean this interval, right? So that means, so we are saying x belongs to a comma infinity and y belongs to a comma infinity. X and y are two arbitrary points in this domain. That means we have that x is greater than a and y is greater than a. Do you agree? X is greater than a, y is greater than a. That means 1 over x is less than 1 by a, and the other portion same thing for y, right? So I can find the estimate here. This thing is less than or equal to what? Mod of x minus y 1 by a square. So here it should come what? Should I write down like this? Is it okay? Right? Yes. So now you see, I have estimated this. Now I have to show that this should be function of epsilon. If this is, I have to find a relationship. I need to look at this. What is the relationship between x, y, and delta? If this is less than delta, what should I choose here? Delta. So I can choose delta to be, if I choose delta is equal to epsilon into a square, will it work? Right? अब ये कैसे आया? ये तो ऑब्जर्व करके आया ना, और तो कुछ नहीं है, राइट? आई एम जस्ट ऑब्जर्विंग कि कैसे ये सेट करे इसको, राइट? So it is clear that if I choose delta is equal to epsilon into a square, we are done. Right? The whole thing will be less than epsilon. Right? For this value of delta. हो गया. So the function is uniformly continuous. Right? Got it? Now, अभी हम थोड़ा सा इसका डोमेन चेंज कर देंगे, there will be a problem. And I think earlier also I have shown it to you. If I say that function is this, sorry, function is this, and suppose 0 comma infinity है domain. Is it uniformly continuous? अब there will be a problem. वो हमारे पास A नहीं है, right? जिससे हमने सब मैनेज कर लिया था. Now there is a issue, right? So obviously looks like this is not uniformly continuous, but how will you prove it? So luckily there are certain other characterizations which I would like to mention to you. One of them is, if you can show that, now you see, so I should write, say F is not uniformly continuous if this condition holds. There exists epsilon positive, there exists epsilon positive such that for every delta positive, there are points x comma y in the domain D, right? Such that when we have this is less than delta, then we have mod of f of x minus f of y, mod of f of x minus f of y. अरे यार बहुत प्रॉब्लम है यहाँ. Greater than epsilon. So if you want, I can take, say, normally हम epsilon लेते हैं, so I can take it epsilon naught, some number epsilon naught, right? For some specific epsilon, I have to arrive at this. Then we are done, right? This is bigger than epsilon naught, right? These 2 points are not closed. The images are not closed, right? X and Y are 2 close points in the domain, but the corresponding images are not closed. They are going away than a fixed number, right? So this is another characterization that you can use for showing the function is not uniformly continuous, right? So in this case, I think you can do that, right? In fact, this can be, कई बार इसको दिखाने में थोड़ा सा tricky होता है, थोड़ा lengthy होता है. So another characterization is there in terms of sequence. You take two sequences xn and yn which are close in the domain, right? So mod of xn minus yn is less than delta. Show that the corresponding images are bigger than epsilon. So mod of f of xn minus f of yn is, right? So I think another characterization so this is also one characterization. So what I'm doing, I'm taking one epsilon for which this is bigger. That is enough to show that it is not, right? Here I don't have to show that for every, right? If I have to say something in negative, just choose some epsilon for which you are in a problem. Any question at this point? Clear? You have to show that something is not uniformly continuous. This is the characterization that you can use. Take 2 points, arbitrary points in the domain, and which are close. So mod of x minus y is less than delta. And look at the corresponding images. Mod of f of x minus mod of f of y. If it is bigger than epsilon, for some epsilon, so I say bigger than epsilon naught, then there is a problem for that epsilon, right? Okay, so this is not uniformly continuous. So I leave it to you for this function to do this. Okay, I mean, in fact, मैंने तुमको जो example sheet share करी है उसमें सब दिया हुआ है, पढ़ सकते हो. अगर नहीं कर पा रहे हो अपने आप, in the worst case scenario, at least understand the concept really well, right? Now, another characterization is there. Another characterization is there. F is not uniformly continuous. And this is also sometimes quite easy. I mean, people use it quite often. If there exists epsilon naught positive, so some specific epsilon, okay, and two sequences xn and yn, as I mentioned, two sequences xn and yn in the domain D, right? Such that when we have the limit xn minus yn is 0, then we have, if you can show that f of x of n minus f of y of n is bigger than equal to epsilon naught for all So this is also another characterization in terms of sequences. I think you remember I told you about if the function is continuous at a point, there is a sequence characterization, right? If xn is converging to a point x, and you can show that f of xn converges to f of x, then the function is continuous at that point. Okay, so that is there, right? Or say if xn converges to a point a and f of xn converges to f of a, then the function is continuous at x equal to a. Okay, so if I have to show that it is not continuous for some epsilon, I have to arrive at a contradiction, or in other words, the inequality is not true. So this is the opposite sign here. This is bigger than this, right? Right. So now in this case of 1 by x, what you can do? One x sequence could be xn is equal to 1 by n, right? And yn could be say 1 by n plus 1, and you can see the thing, right? इतना पोर्शन मैंने छोड़ दिया चाय के लिए, चाय भी तो पीनी है शाम की, right? xn is equal to y 1 by n दे दिया, yn is equal to 1 by n plus 1 दे दिया. Now you can show that in case of 1 by x there is an issue, right? Got it? Any question? भी crystal clear हो गया यूनिफॉर्म क्वांटिटी, राइट? अब क्या कितना बचा? सारा तो हो गया, 1 घंटे में तुम्हारा पूरा कोर्स पढ़ने की जरूरत है कुछ? Okay, so we are done with the 6th item, right? Continuity, uniform quantity, function using epsilon delta and examples हो गए, हर एक यहाँ तक हो गया. तो 3, 4, 5, 6 जो मेनली एप्सिलॉन डेल्टा बिजनेस पे था, दैट इज डन. यही थोड़ा सा मुश्किल लगता है, बाकी तो सब आसान है, राइट? डिफरेंशिएबिलिटी तो पढ़ते आ रहे हो तुम, राइट? यू कैन डू दिस विद एप्सिलॉन डेल्टा आल्सो, राइट? बिकॉज लिमिट इन्वॉल्व है, लिमिट का मतलब यू कैन कन्वर्ट इनटू एप्सिलॉन डेल्टा थिंग विद स्ट्रेट फॉरवर्ड. हाँ, एग्जांपल ऑफ डिफरेंशिएबल एंड नॉन डिफरेंशिएबल फंक्शंस. गिव एन एग्जांपल ऑफ अ फंक्शन डिफरेंशिएबल एट 5 पॉइंट्स. मेरे ये फेवरेट हैं एक्चुअली, राइट? और 7 पॉइंट्स, इनको कंस्ट्रक्ट करने में दिमाग लगता है. So if somebody is making progress, मैं हाथ पकड़ने को तैयार हूँ. And if you will not attempt, it will remain there, right? Okay. So that's about 7. ये भी हो गया. Rolle's theorem, mean value theorem, maximum, minima. So maximum minimum derivative negative है, positive है at a point. All those things you know already, right? Mean value theorem का specific case Rolle's theorem हो गया, right? ये L शायद 2 होने चाहिए थे, right? Anyway, forget about it. So Rolle's theorem and mean value theorem. इसका application है solving root and so on, determining a root of a function. I think last tutorial we have given some examples like that. वो तो आसान काम है. वो जो बहुत आसान होता है, I don't do it actually. टफ पे फोकस करो, ब्यूटी पे फोकस करो बेसिकली, राइट? सो यू विल एंजॉय. तो और क्या बचा? टेलर सीरीज. So if I have to show that some function has a Taylor series, what you need to do? Write down the Taylor polynomial and use that absolute value of Taylor polynomial less than or equal to that Taylor's inequality, and then take the limit. So you can show that there is a power series which exists. Radius of convergence. How will you find radius of convergence of a series? So sigma an x power n or x minus a raised power n. So you know capital R is equal to limit n tends to infinity mod of an by an plus 1. कुछ लोग कंफ्यूज होंगे, 1 by r is equal to something something, वो रिवर्स है, so it doesn't दोनों चीजें सेम ही है, right? Okay, so limit n tends to infinity mod of an by an plus 1 is r, the radius of convergence. What is radius of convergence? It's a size. So r is what? Size of that neighborhood where the value, if you take the values of x in that neighborhood, series will be convergent. You can find the sum. Okay, that's all about radius of convergence. तो हमको तो ट्रिकी क्वेश्चंस पूछने की आदत है, जैसे गैप सीरीज मैंने कल तुमको बात करी थी लास्ट टाइम, राइट? हाउ डू वी एस्टिमेट द वैल्यू? ऐसे सीरीज तो मैं बहुत सारी बना सकता हूँ टू पुट यू इन सम, टू ऑब्जर्व यू सम ब्यूटी, राइट? सो दैट इज फाइन. ये हो गया. सो व्हाट इज लेफ्ट? ओनली आइटम नंबर 2 विच इज काउंटेबल एंड काउंटेबल. बाकी तो हो गया. तो मैं दोबारा उसको भी स्ट्रेस कर देता हूँ, राइट? ओके, हो गया पूरा कोर्स रिवाइज. Again, thanks to Professor Bush, I am using his slides with permission. Anyway, so countable sets. Now you see, if something is finite, you can always count. If something is finite, you can always count. If something is infinite, then you have to find whether I can count or not, right? It is something like that. Since natural numbers, right? Natural numbers 1, 2, 3, 4 is our standard reference point, right? कैसे count करते हैं? 1, 2, 3, 4, 5. So I'm doing an assignment with natural numbers, right? If it is finite, I can easily count. But if it is infinite, and if I am able to produce a natural number all the time I am counting, so that means if we can establish one-to-one correspondence with the set of natural numbers, I can count infinite sets. I can say that they are countable or not countable, right? That is a very basic definition. Now, I have taken this definition specifically, although in mathematics, they say that if you are able to, so this, if I use one-to-one correspondence definition, I would say that I am looking for a function which is one-to-one and onto from set of natural numbers to the set which you want to show that it is countable. Okay. Although you can, this is a little bit a stronger definition. If I can drop the onto word, if the function is only one-to-one, then also you can find that the set is countable. That's perfectly okay. So don't confuse in both of them. मैं तो आसान चीजें लेता हूँ यहाँ पे, right? One-to-one function करना है तो ठीक है, onto वाला कर दोगे तो भी चलेगा, right? So if it is one-to-one and onto, that's fine, right? So that's what I have taken. So if I have to show that something is countable, so there are two things. Given a set, either it is countable or uncountable if it is infinite, right? So in case of countability, you have to only do one thing: find a one-to-one and onto function from set of natural numbers to that set. Full stop. And in case of uncountability, use Cantor diagonalization argument. Beautiful. बस हो गया ना? कोई और क्वेश्चन है? और वैसे तो ये स्लाइड्स हैं, तुम दोबारा ही देख सकते हो, सब कुछ पढ़ा हुआ है, राइट? यू कैन एंजॉय. एनी फर्दर क्वेश्चन? तैयारी हो गई? अब तो सब हो गई ना तैयारी? अभी करना क्या है, एक चाय का कप लो, एक एक क्वेश्चन सबका कर डालो एक्चुअली चाहो तो मुश्किल से 2 घंटे लगेंगे तुम्हें रिवाइज करने में सारी चीजें, राइट? बाकी दिन पढ़ना ही नहीं है कुछ. हाँ, जो ब्यूटीफुल प्रॉब्लम्स हैं उनके लिए सोचना पड़ेगा. क्यों, क्या सोच रहे हो? एनीवे, हाँ, एक बार कैंटर डायगोनलाइजेशन आर्गुमेंट में दोबारा दिखा देता हूँ. उसमें थोड़ा सा लोगों को दिक्कत आती है. इवन इंटीजर्स काउंटेबल है तो बहुत ही आसान है, राइट? यू कैन फाइंड द फंक्शन. रेशनल नंबर्स का फंक्शन अभी तक तुमको मिला नहीं होगा, गूगल पे सर्च किया, मिल गया? मेरे पास है तो, पर मैं दूंगा नहीं. So you have to come up with that function anyway. So rational numbers are countable because you can do this kind of counting, right? Assignment. So normally the function has to be in the height of a function, right? You can put 0 there and put negative numbers, so everything will be included in this list. Okay, uncountable set. So I am giving you the proof if S is an infinite countable set, power set is uncountable, right? So in each of these questions, you assume that it is countable, write down the list, right? So here, each power set element corresponds to a binary number, right? So whichever element is present, you put 1, otherwise 0. So there is a binary string for each of them, right? And then, so we assume that the power set is countable. So suppose we can enumerate the elements of the power set as T1, T2, T3, and so on, right? These are the elements of the power set. And then, so this is the first element, second element, third element, like that. We assume that it is countable. So each power set element can be represented by a binary numbers. In case of open interval 0, 1, it will be decimal expansion. So remember, right? Okay. Now, I have to produce a number T which is not in this list, which is actually an element of a power set, but which is not in the list. कैंटर ने इतना सोचा कि कैसे हम एक एलिमेंट प्रोड्यूस करें T which is an element of a power set but which is not in this list. So उसने बोला डायगोनल पे फोकस करते हैं, राइट? लेट अस फोकस ऑन द डायगोनल्स. तो जो हमने T लिया उसका पहला टर्म होगा कॉम्प्लीमेंट ऑफ 1, जो T1 का पहला वाला है उसको 0 कर दिया. सेकंड वाले में 1 है उसको 0 कर दिया, सेकंड एलिमेंट ऑफ दैट. थर्ड में 0 है तो उसको 1 कर दिया. फोर्थ में 0 है तो उसको 1 कर दिया. Like that you can keep on continuing. So this element T is an element of a power set because it's a binary string anyway. Any binary string corresponds to an element of a power set. But this will never be in the list because the way we are constructing, it will differ at the diagonal all the time. Suppose T is equal to Ti for some I, right? But then it will differ at Tii, right? The diagonal element will be different because reverse or complement. In case of decimal expansion, we are taking, say, 9 minus whatever that number is there occurring in the decimal expansion. If it is 5, 9 minus 5 is 4. If it is 6, 9 minus 6 is 3, and so on, right? That's all about when you want to show that open interval 0, 1 is uncountable, right? Okay. Similarly, you can say that real line is uncountable. Countable union of countable set is countable. Okay. One can ask, एक बड़ा सेट है, उसके अंदर एक छोटा सेट है जो कि अनकाउंटेबल है, तो बड़ा सेट काउंटेबल होगा कि अनकाउंटेबल होगा? या तो ये इस तरीके के क्वेश्चन तो पूछ ही सकते हो चाय पे बैठे बैठे और फिर प्रूव कर सकते हो. ओके, सो आई थिंक दैट्स ऑल. आज का लेक्चर 4 क्वेश्चन है, पहला, दूसरा, तीसरा, चौथा. Again, I am reminding you that you have to write down on the question paper itself. Do all rough work somewhere else in the rough sheet, which will be provided to you by the examination by the controller of examiner. So you do all the calculations there. I don't want any garbage. Again, remember, I am only worrying about your thought process and approach. It may happen that your answer is correct, but your approach is wrong. You will get 0. It may happen your answer is wrong, but your approach is correct. You will get full marks. Okay. So these things are possible. So don't compare. अरे मेरे को तो 5 नंबर दिए, उसको 3 नंबर दिए, ये सब नहीं चलता. Right. Okay. So anything is possible. Okay. Right. अब ऐसा भी हो सकता है कॉन्ट्रडिक्शन जब हम अराइव कर रहे हैं एप्सिलॉन डेल्टा में. इफ आई हैव टू शो दैट समथिंग डज नॉट एग्जिस्ट, इसने एप्सिलॉन इज इक्वल टू 2 लिया, किसी ने एप्सिलॉन इज इक्वल टू 4 लिया, किसी ने एप्सिलॉन इज इक्वल टू हाफ लिया, तो बाकी तो आंसर अलग आएगा ना. ये भी हो सकता है, ऐसा नहीं कि यार उसने अब हाफ लिया तो हम भी हाफ लें. राइट. ओके, सो दैट्स ऑल फ्रीडम, राइट? दिस इज नॉट स्कूल एग्जाम, दिस इज नॉट IIT JEE एग्जाम, दिस इज यूनिवर्सिटी एग्जाम सिस्टम. Okay, 4 questions. So although I am a bit busy, but still you can send me a message if you are in trouble, and you can ask me, or you can approach Sudeep Bera also, no problem, right? Anyone, right? I think they are planning one tutorial also for the last one, right? Which घर मत जाया करो भाई, बीच में ये सब problems होती हैं, right? You go to home and then all kind of issues are there. Finding room is problem, finding common time is a problem, right? So don't do that until your December 20th, right? Final exam, right? Okay, wish you all good luck. Thank you.